Bismillahirrahmanirrahim. Assalam O Alikum, dear student. Welcome to my YouTube channel, Learn with Azam. Today we will discuss about new syllabus Physics SSC2, Unit number 10, Simple Harmonic Motions and Waves. Today we will discuss SLO based FBISE requirement according to the new paper. So today we will discuss MCQs and short questions of question number 1 to 5 in part 1, remaining in part 2 inshallah. In question number 1, multiple choice questions. In first, a mass spring system has a mass attached to a spring. What will be the effect on its time period if the mass is increased 4 times? According to the statement, the time period of mass spring system T is equal to 2 pi m over k square root. So time period we can find when mass is 4 times. Putting the values 4m, then 4 square root is 2. Then time period will be double. So in this statement answer is become double. Now in second statement, a spring is stretched 5 centimeter by 20 Newton force. What is its spring constant? We can find the value of spring constant K by using the formula of Hooke's law. F is equal to Kx. Then putting the values, but first of all change x into meter. Here given is a 5 centimeter. So x is equal to 0.05 meter. Then answer become is 400 Newton per meter. Similarly, in third statement, if amplitude of simple pendulum is double, what will be the happen on time period? In this statement, time period and amplitude of simple pendulum does not depend on each other. So both are independent. So the value of time period remains same. So answer is D part remain same. In fourth statement, the time period of simple pendulum will be smallest at. Here we value of time period of simple pendulum T is equal to 2 pi L over G square root. So the value of G depend upon the time period. So its value is smallest at point C poles. Now in 5, if a body performing a simple harmonic motion complete one revolution in 2 seconds, its frequency of vibration is. So frequency is the reciprocal of time period. F is equal to 1 upon T. So 1 divided by 2 is equal to 0.5 Hertz. So C part 0.5 Hertz. In sixth statement, 360 waves are passing through a point in a river in 1 hour. Time period of the wave is 0.1 second, 1 second, 10 second and 100 second. So time period T is equal to time divided by the number of waves, because we know that frequency F is equal to number of wave divided by time. So time period is the reciprocal of frequency. So capital T time period is equal to small t divided by n. 1 hour is 3600 seconds. So 3600 divided by 360 is equal to 10 seconds. Now in 7, time period of electric vibrator of ripple tank is 0.5 seconds. Water wave in a ripple tank has the speed of 10 meter per second and amplitude of 5 centimeter, the frequency of the wave. Here, frequency is the reciprocal of time period, so F is equal to 1 upon T. Then 1 divided by 0.5 is equal to 2 Hertz. So the answer of 7 part is D, 2 Hertz. Similarly, in statement 8, which one of the following is a longitudinal wave? Sound wave produce a longitudinal wave, so answer is D part, sound wave. In 9, when water waves enter from deep water to shallow water, then what will be changed? Speed of water wave will be decreased. And in last MCQs, listening to radio transmission in deep valley of mountain area is due to the reflection of wave. So the answer of 10 part A, reflection of wave. Now we will start conceptual questions. In question number 1, given statement, give an example of vibratory motion which is not a simple harmonic motion. Give a reason with your selection. Here we can give some answers. You choose the best answer and write it. First of all, we write the answer. It is very simple. A fan is rotating with constant angular velocity. An object back and forth about its mean position periodically with constant speed. Earth revolving around the sun and perfectly elastic basketball bouncing on perfectly rigid surface and etc. are all example of non-harmonic periodic motion. Explanation: we can explain this type. A simple harmonic motion is one of which the object moves to and fro about its mean position, and the restoring force on the moving object is directly proportional to its displacement in either in the direction. In this motion, the speed of the moving object is zero at the extreme position and maximum at mean position, just like in a pendulum, where the bob stops at the extreme position, zero speed, and attain the maximum speed at the mean position. At the bottom most of position of bobs. All the other periodic motion which do the not satisfy this condition are not in a simple harmonic motion. So like the example I state above, like the angular speed of earth or fan is a constant, not zero or not maximum at any position. Also, the earth or fan is not working back and forth motion. They are just moving in only one direction. In a basketball, although the speed of ball is maximum at the mean position at the ground and zero at a extreme position, it does not move back and fro motion about the mean position. Neither is the force proportional to the displacement. So this answer is complete. Now we will explain in an other answer. We can justify with other example. So we have basically because it is not sinusoidal. If you plot the vertical position various time, you will have a series of parabola with the sharp turn. around the each time it is the ground. It is oscillatory but not a sine wave. So they not produce a sine wave. So we have explained that another way of looking at it is the gravity pull down on the ball with a constant force for a most of the motion and the earth push up it sharply for very short period of time. For simple harmonic motion, the net force always acts toward the equilibrium position and the force is proportional to how far the thing is away from equilibrium. Now we have another answer what is meant by oscillatory motion. Here, first of all, define the oscillatory motion, a periodic motion which perform back and fro motion about its mean position is called oscillatory motion or vibratory motion. For example, motion of swimming and etc. Now, simple harmonic motion that is stand for SHM, simple harmonic motion, a special type of oscillatory motion in which two conditions are justified. Number one, motion acceleration is always directly proportional to its displacement. Here we can say that acceleration of a body is directly proportional to its displacement and it is always directed toward the mean position. And second, acceleration is always directed toward the mean position. So these 2 points are satisfied in a simple harmonic motion. Acceleration is a directly proportional to displacement and acceleration is a always directed toward the mean position. Now, example, motion of an elastic strip or motion of bob or etc. These are the example of simple harmonic motion. Now, we have explained every simple harmonic motion is oscillatory motion, but every oscillatory motion is not a simple harmonic motion because oscillatory motion may not be satisfied these two conditions. Now, another answer for explaining of question number 1. So we have yes, when a ball is dropped from a height on a perfectly elastic plane surface. If the motion of the ball is oscillatory about but not in a simple harmonic motion, as restoring force F is equal to mg or F is equal to W or W is equal to mg is equal to constant. But for a simple harmonic motion that is required to the mean position, then F is directly proportional to minus Y. This means that force is directly proportional to its displacement and always directed toward the mean position. Now, the question number 1 have 5 answers and explain very carefully. Now we will move from question number 2. In question number 2, the given statement at extreme position velocity is 0 but acceleration is maximum. In simple harmonic motion, how can you theoretically explain it? Now, given the answer of first part, for any one-dimensional motion, not just simple harmonic motion. We can also explain that what is simple harmonic motion. So here this answer is for any one-dimensional motion is not just a simple harmonic motion. Acceleration is 0 when the velocity is at a maximum or minimum. Now that follows from the fact that acceleration is the rate of change of velocity. Think about it. So we have, as the velocity approaches to a maximum or minimum, then it will be increasing. After it's reaching a maximum and start to slow down, it will be decreases. So the acceleration change sign. It passes through a zero at precisely the moment when the velocity is at maximum. So another answer for explanation of this question, acceleration is zero because at a point it is the mean position, which is mean that it is the equilibrium position or at a mean position. So we have is the spring is not compressed or extended, so the pendulum of the surface is not tangential force, then the acceleration will be zero. However, at the point due to the velocity being non-zero, the object crossing the mean position according to the law of inertia or Newton's first law of motion, and the acceleration again become non-zero. So the process continue and simple harmonic motion take place. It is not that velocity is a maximum, that is why the acceleration is zero. The velocity is maximum, therefore because the acceleration change the direction at the point. Hence, at all the points the acceleration is decreasing the object. So we have an other answer for this question of question number 2. We can choose any answer. All answer is related to the question number 2. In other answer, when the mass reached at a maximum equilibrium position, there is no restoring force. For explanation, we have the acceleration therefore is zero, but the mass is moving at its height, the velocity, because of its inertia. The mass will be continue past the equilibrium position and touch the string. Now we will move the question number 3. What will be happen to the acceleration of a mass spring system if its mass is double? Here the simple question, if the mass is double, what will be the acceleration? Now we have explained this question. Thus acceleration of a body become half. Why? If the mass of the body is doubled when the same force is applied. According to the acceleration of a body, according to the Newton's law, F is equal to ma. So A is equal to F upon m. So A is inversely proportional to its mass. In this value, we can see that in this equation, acceleration and mass are inversely proportional. If mass is double, then the acceleration will be half. Thus, the acceleration of a body become half if the mass of body is doubled when the same force is applied. Now we have the force is constant of the spring is independent of the mass attached to it. No, therefore it does not change with the mass that attached. So both are the explanation of acceleration of mass spring system. Now we have moved to question number 4. A simple pendulum has a time period t. What will be the happen to its the time period of thread length is shortened to half. Now in question number 4, so if we reduce the length of the string by half, then the time period will be square root of 2 times the initial time period. because we conclude that time period T is equal to 2 pi L over G. So this problem is directly based on the formula T is equal to 2 pi L over G square root. Then the new time period will be 2 square root time of the initial time period, or for this answer we can see the previous question by mathematical form. Now we have today last question, question number 5. A simple pendulum has a time period of 4 seconds. What will be its time period remain same or change if its steel bob is replaced by the wood of the same size? Now we have explained the answer. The time period will remain the same because the time period of simple pendulum T is independent of mass. So the time period of the simple pendulum is given by T is equal to 2 pi L over G square root. Clearly that the time period is independent of mass of the bob. Now another answer for the explanation of question number 5 we have. Therefore, from the given equation, we know that the periodic time of the pendulum does not depend upon the mass of the bob. And so it does not matter that material of the bob is made. So we have its time period remain the same. Best of luck in next question with next video.